Hi folks, Mr. Long here. I'm going to do some factoring today of using strategies you would use for quadratics, but we're not actually going to be factoring quadratics. Specifically, what we're going to be doing is factoring things with x to the fourth in them. We can do x to the sixth, we can do just regular x, but anything that has a quadratic pattern. And you're going to see what that means right now. So we're going to start with this example right here. X to the fourth plus 8x squared minus 9. And specifically, what you're going to notice here is that 4 there, 2 there, and then a constant term at the end. And how is that similar to this pattern here? So let's look at this. Okay, so if I look, x to the fourth plus 8x squared minus 9, it does have the same pattern as x squared plus 8x plus 9. So here you've got 4, 2, constant. Here you've got 2, 1 constant, right? Because if you notice, there's a 1 there. We don't typically treat that as a 1 or write the 1, but it's got that pattern. So anytime that you have a polynomial function or a function with fractional exponents, as long as you have this pattern here, x to the 2n, bx to the n with a constant of c, you can factor it and work with it as if it's a quadratic, okay? So if your exponents follow the pattern 2n, n, and constant, you're good to go. So let's go back now to this example and do some factoring. Okay, so what we always do though, you'll remember that this term here, the 8x squared, that's always our x term in a quadratic, right? Normally we'd have x squared plus 8x minus 9. So what we want to do is we want to take that 8x squared and we want to make that our x term. Well, we've used substitution before. We're going to do it again. So what I'm going to do is I'm going to set u equal to x squared. That way we get rid of x squared and we get u. But what is x to the fourth going to be then in terms of u? Well, I'll drag that down a little further, and all I need to do is square u, and I get x squared squared. Well, we know by our exponent laws that we multiply those two exponents and we get x to the fourth. So now I can replace x to the fourth, as you're going to see down here. I'm going to replace x to the fourth with u squared, and I'm going to replace x squared with u. And now I just treat it as a quadratic. Okay, just treat it as a quadratic. So let's see here. So what I'm going to do then is go through this and factor it. So I need to get two numbers that multiply to -9, m, and add to 8. So numbers, when these two numbers differ by 1, like not considering the signs, when they differ by 1, have a difference of 1, 1 is going to be one of the numbers, because 1 times 9 is 9. So that means that 1 and 9 are the two numbers. Now specifically, what am I going to put on that? So 1 is going to be one of the numbers. Is it positive or negative? Well, multiplies to -9, adds to positive 8. That means the 1 is a negative. Okay, the 1 is a negative. There we go. So it's -1, positive 9. Now we can go through this process of factoring it out. So we have that. U plus 9, u minus 1 equals 0. So I solve for u. Set each factor equal to 0. That's zero factor property. U equals -9 or u equals 1. And then, but that's not really u. It's actually x squared. So now I solve with respect to x squared. So x squared equals -9, x squared equals 1. X squared equals -9, well, there's nothing I can square and get a negative, so that doesn't exist. But what about x squared equals 1? We know that we get plus or minus. Okay, so now what I'm going to do is do a sketch. Okay, I'm going to do a sketch. So I know that I've got x-intercept, so plus and minus 1. And I know the y-intercept is -9. So I'll bring this over here so you can see it a little better. And now we need to go ahead and graph that. Okay, we're going to go ahead and graph it. So what will we do? We will sketch, I see the y-intercept is -9, so I'm down here at -9. And I notice it's x to the 4th and 8x squared. So even though the 8x squared will dominate locally, x to the 4th and 8x squared pretty much look the same. So it's just going to do this. Okay, that's what it'll look like, passing through 1 and -1. Okay, so so really what it was, I could have mentioned that if we think of our sums, it would just be x to the 4th, right, like this, plus 8x squared. And once I have that graph, then I drop it down by 9. Okay, I drop it down by 9. And that's our graph. So we factored and solved that. Let's try one more. Okay, this one here we're going to solve by factoring. And this one here is looks pretty weird, right? X minus 5 root x minus 36 equals 0. And we're going to factor this by solving, solve this by factoring. And so the first thing I'm going to do is I need to see if it follows that pattern. Okay, does it follow that pattern of x to the 2n, x to the n, and constant? So a quadratic is 2, 1, and a constant. So anything with that pattern. So 1 is double of 1/2. Oh, it's the same pattern because 2 is double of 1. So 1, 1/2, and constant, that's the same pattern. So I want to get the middle term to be u. Okay, that x. X to the 1/2 needs to be u. So what do I need to do? I need to set x to the 1/2 equal to u. And then I'm going to square both sides. And I'll end up with u squared minus 5u minus 36. So you're always going to be factoring things in terms of u squared, u, and constant, always. And all you have to do is look at that middle term and set that equal to u. Okay, so that's another nice easy one. Two numbers that add to -5 and multiply to -36. And I'm thinking for those, well, 9 and 4 multiplies to 36. And which one of those would have to be negative for it to add to -5? Well, the -9 would. Okay, the -9 would. So it would have to be negative. There we go. So now I can just put it into its factors. U minus 9, u plus 4. Okay, u minus 9, u plus 4. And now I can solve that. So set each factor equal to 0. Okay, so u equals 9, u equals -4. And then, but it's not u I want to solve for, it's x, and u is worth root x. So root x equals 9 or root x equals -4. Now, root x equals 9 is a reasonable answer. What about root x equals -4? Is there anything, like, can the root of a number equal a negative? Like, I can square both sides, right? And then I would get x equals 16. But that doesn't make any sense. The root of x is a negative. Is there any number that I would square root and get a negative? It's not possible. So this one here does not exist. On the other hand, root x equals 9. I can square both sides there, and x will equal 81. So I have one solution only, and it's x equals 81. Let's look at the graph. This is a nice one to graph. It's actually a really nice one to graph. And it'll make a lot of sense, I think. So as we go through and graph this one, what we're going to do is think about this in terms of local and global dominance. So I've got the x to the 1/2. So we know that the x will be dominant globally. It's got a higher exponent. We know that x to the 1/2 will be dominant locally, -5x to the 1/2. So that's just like the square root graph, but it's flipped. It's a vertical reflection. So we have a pretty good idea there what's going on. I'm not going to worry about the negative 36 yet. So I'm just going to go and sketch this. So locally, it's going to look like that, right? Because it's a vertically reflected square root function, x to the 1/2. I know that globally, it's going to look like x. So now all I need to do is to join those up, right? It's just like we were sketching earlier. Oh, by the way, I know it's x to the 1/2, so the graph has to start at right here. It can't go anywhere else, right? It can't go into the negatives because I can't have negatives evaluated to the 1/2. So then it's just going to join those there like that. Okay. Now, that's if I didn't have the minus 36, but I do have the minus 36. So now I need to drop it down by 36. So that will be negative 36, and it will start by decreasing, and then it will increase just like up here. Okay? And the nice thing is it gives us an answer. An answer of 81 there is very reasonable. Okay, so there's our x-intercept at x equals 81. So you can see how all of the things that we've already learned about polynomial functions applies as we learn more new things, okay? So that's what is for many people is a very tricky graph. For you, it won't be so hard at all to do. Okay, and I think we have one more here in this type, and we're just going to do a bit of factoring on this one. That's it. So really what we're going to do here is take a look at this, negative 4x to the 4th minus 6x squared plus 18. So it follows that pattern of 4, 2, constant, right? 2, 1, constant. So whatever I have here in the middle term, I set equal to u. So u is going to be x squared, therefore u squared is going to be x to the 4th. So now what I do is I simply common factor out negative 2 because 2 is a factor of all three terms, and the leading term is negative. So I factor out negative 2, and then that means I divide all of these terms by negative 2. So I end up with 2u squared plus 3u minus 9. And if you remember here, I have to take the a term, a, or the a coefficient, which is 2, and the c value, which is negative 9. I multiply those two together. I get negative 18. My two numbers that I'm interested in have to multiply to negative 18, and they have to add to the middle term 3. So 18, 6, and 3 right there, but will it be a positive negative? Well, it multiplies to a negative and it adds to a positive. So that means the positive is bigger in terms of size. So that would make the negative 3, or the 3 negative. Okay, so 6 and negative 3. Now, what I'm going to do here is I'm going to take that and I'm going to put it into the grid. Okay, I'll put it into the grid. And so I just write it. Doesn't matter as long as I have the u squared term in the top left and the constant in the bottom right. I then go factor horizontally and divide vertically. Okay, factor horizontally, divide vertically. So if I look, what are the common factors? Well, right there, 2 is definitely a common factor, and so is u. Then on the next line down, I've got a leading negative. Okay, that negative right there. And then I've got, so negative 3 is the only common factor. Okay, and then what I'm going to do is divide across the top. So I've got 2u squared divided by 2u, which will make u. And then I've got 6u divided by 2u, which will be plus 3. So then a factored form for this will be, and I'll start with, it will be 2u minus 3 multiplied by u plus 3. But we need to write that in terms of x, and we remember that u just equaled x squared. So I'm going to end up with 2x squared minus 3 multiplied by x squared plus 3. So if I was solving this, right, though, I definitely wouldn't have have any solutions for this factor, right? Because I've got x squared, a parabola, but it's shifted up, so I don't get any x-intercepts for that. This one, on the other hand, I definitely would get x-intercepts. So this one I would just set 2x squared equal to 3. I'd add 3 on both sides, divide by 2, and square root, okay, to get my 2 x-intercepts. But this right here would be the factored form, okay? So that's the process for factoring trinomials as quadratics, even when you don't have x squared and x terms. Okay, we just use that pattern, x to the 2n plus x to the n plus a constant. Okay, so good luck with your practice questions.